Hello friends, so today we are going to start this activity number 11.15 from the 11th chapter work and energy, and the most important term of the chapter is law of conservation of energy. So the important point in this activity we have to learn is based on the very important formula of law of conservation, in which the total of the potential energy and the kinetic energy is constant. So this is the actual law of the conservation of energy. Potential energy is known as EP and kinetic energy is known as EK, and constant the value we get. So this is one thing. Now if we put the formula of potential energy EP is equal to mgh and kinetic energy EK is equal to 1/2 mv square. So this is the simplest thing which are to be keep in mind, and by considering this we can get that mgh plus 1/2 mv square is constant. So this is the very important formula of the conservation of energy law, and this is we are going to understand with one example. As per your activity, the question is given an object of, as per activity, object of mass 20 kg. So mass, friend, is given of an object in 20 kg and it is constant. Then it is dropped from a height 4 meter. So height is given as 4 meter, right? And it is falling on the ground. Here are some important things given to you to note it down, and these important terms we are going to learn how it is to be calculated. So calculations are here. So first of all, the height is taken in first column. Unit of height we will consider in meter as per given in your activity. And friends, the potential energy, so potential energy value you will get, that is, friends, EP, and EP's formula is mgh, its unit is joule. Then kinetic energy, this kinetic energy has the symbol EK and 1/2 mv square. This is its formula and its unit is once again joule. And finally, friends, we will have the total of this both, and so in last column we will consider the total energy, and this total energy is EP plus EK, and that also in joule. So every time we will not put the units, but here the values are given. So this is 4 meter first, then 3 meter, then 2 meter, and then 1 meter. So this is one by one object is coming down from a 4 meter height to the 1 meter height. So height is, friends, also we can say height is also distance from ground. So it is to be considered as per requirement. Okay, so let's start to find out the values. So first of all, in first place, if you want to find, okay, value of G is taken, is given 10, it is to be taken 10 meter per second square. It is also given in your activity. So let's start first, friends. First EP is mgh case 1. So M is mass is 20 kg, G is 10 meter per second square is to be taken. H, height is 4 meter. For first case, height is 4 meter. So this is mgh and this is 800 joule. So this is 800 joule, our first answer, friends, of the potential energy. At the same time, what should be the EK? EK is equal to 1 half mv square. 1 half m is 20 and v is 0. At initially, friends, v is 0 because object is at 4 meter height, and at 4 meter height object is not allowed to fall, and that's why it is 0, and that's why the total is 0. So the potential energy is 0. You can see 800 plus 0. So this is total energy 800 joule. This is first over. Now what is for second? So second case, friends, the height is 3 meter. Now this is most important term for here. EP is equal to, once again, mgh. M is 20 kg, G is to be taken 10, friends, and height now is 3 instead of 4. So we have to take here 3 and we can get the answer 600 joule. So here the answer we obtain is 600 joule. Now the most important term is to find the potential energy for this case. So for this case, potential energy is 600 meter and kinetic energy is 1 half mv square. So what is V? Value of V is unknown for us, friends. So we have to take help from one more formula which you already learnt. In this formula, we are continuing this here. EK is equal to 1 half mv square. V is unknown for us, friends. And to find out V, we will use the formula v square minus u square is equal to 2as. This formula of acceleration is to be used. Initial velocity u is to be taken 0, v is to be find, a is acceleration, that is 10 meter per second square, because this acceleration is due to gravitation, and that's why value of a is to be taken 10, and the s distance. Now how to distance is to be find. So this distance, initial distance was, friends, 4 meter, and we are calculating the distance of 3 meter. So here we have to take the value 4 minus 3, and that's why 1 meter is to be taken the distance s. So now if I put the values here, v square minus 0, 2 into 10 into 1, and that's why v square is equal to 20. So here we get the first value of v square 20. Now if we put this value, friends, in the formula EK, that is 1 half mv square. So it is 1 half, m is 20, and v square is also 20, friends. It is already v square, so we are not putting square once again. It is the whole value of v square direct. So this is 10, and we get the answer 20 into 10, that is 100. So 200. So the value we obtained is 600, and here is 200. You can see the total of this both is equal to 800 joule. One last example I am giving you of similar thing, how to find once again the potential energy and kinetic energy, and we will check either it is constant or not. So in case 3, potential energy is equal to mgh. M is 20 kg constant, G is constant, friends. And in case 3, you can see this is our case 3. In this case 3, the height is to be taken 2 meter. So here I am putting here 2. This is 20 to the 40, 40 into 10, and we get the answer 400 joule. So here we get the answer 400 joule. Now it's time to find out the EK. To find EK, we have to once again consider this formula, friends, in which v square minus u square is equal to 2as. What is s is to be taken? So keep in mind this is last. Initial was 4 and final is 2. So how much distance is covered by object? That is s we are finding out. How much distance? Initial distance was height was 4 meter, and the height where we are calculating the values, that height is 2 meter. So 4 meter was the final initial height, and final height is 2 meter. So the distance covered by object is 2 meter, friends. So v square is to be found, u square is 0, 2, acceleration is 10, friends, and the distance covered by object is 2 meter. So here, friends, v square is equal to 40, and that's why this is 40 meter. If I put here in the formula of kinetic energy, this is m20, and v square, direct value of v square is 40. So this is 10, 10 4 for 10 into 14, 400. So we get the answer 400 joule. So here is 400 joule. You can see 400 plus 400 is equal to total 800 joule. Similarly, friends, if you calculate for this, you will get the same value, and same value in which you will get here. This will be 200 and this will be 600. The total value we will obtain is 800 joule. So this is, we can see the potential energy and kinetic energy total is 800. In all cases it is constant. So we can conclude that, friends, you can see this potential energy is decreased as the object is coming down towards the earth, and it is 800 to 600 to 400 to 200. So this is the decreasing order. Similarly, you can see here, friends, as the potential energy decreases, friends, the kinetic energy increases, because the object is now coming in the motion, and due to its motion, its kinetic energy increases from 0 to 200, 200 to 400, 400 to 600, and when object touch to the ground, friends, this will be 800 and this will be 0. Before it touched the ground, at that time it will be maximum. So, friends, here you can see that the total of the potential energy and kinetic energy becomes constant, and this is called the law of conservation of the energy. So the total of the energy always remain constant. Okay, friends, thank you.